Hi, we are Team 51, also known as Team Spark. I'm Sarah.
I'm Steven.
Oh, I'm Joseph.
And I'm Colin.
And we are working on Project GridBase. Project GridBase is a unidirectional DC-based microgrid aimed at improving energy stability and access in developing areas of the world.
Hi, I'm Joseph, and I'll just be going through the revised block diagram since our presentation. And so since then, we've iterated on our design multiple times and met with like electrical engineer graduate students, one being John Patterson and Doreen, who is a student from Ghana and who's studying ASU. So since our presentation, we've made a lot of revisions, and so this is the first design, which is very similar to our design from our presentation, and it still uses the diode coupling for passive prioritization of the energy sources. However, since our last design, we've iterated on this, and potentially we could be using this design, which instead has the local renewable feed into our battery, which eliminates the need for a battery charger, which simplifies our entire design. And so both of these designs are probably something we'll end up settling on for our finalized design. And so we just really need to get this design sorted out so we can actually start getting the detailed design done.
So one way we're hoping to settle on the best system design is to use an interesting piece of software that our mentor Tyler found. He found the software called Homer Pro, and it's a microgrid-specific simulation software that allows us to enter in a system diagrams similar to what we have, and also pick a certain part of the world that we want to simulate in. And the software is able to use metadata and weather data from those regions to help simulate and figure out what the system will do and how it will react in those environments. So using this tool, we can try out different configurations and settle on the most optimal system design.
So this is the Homer software. This is just, I'm going to give you a quick tour. Like when you first open it, you can choose a location. Right now it's Phoenix, but you can choose almost anywhere on the map where there's data available. And then you can go in and define a specific load. This load is a community load that peaks in July, so in the northern hemisphere. And then you can add different components here at the top to your system, and you can get like kind of a basic schematic of what your system's going to look like. You can also define like how the load following works, how the cycle charging for the battery works, and whatnot.
As far as the future goes for our project, we have plans, for the next semester and in the second portion of this class to test our project and our design using this simulation tool, refine our design based on those testing results, and then move on to the physical design and testing, refining, and retesting.
Thank you for watching.